So, how's everyone doing? Now the projector was on. This is the last day before the test begins, so let's go over. My plan for today is to go over any and all possible pertinent information that you could need to study for the test and then take said test. Before that, any questions from you guys at all? I'm thinking mainly anything from Chapter 9, possibly Chapter 9 homeworks and quizzes, anything like that. Anything at all here at the start before I start going over all the test things that are in the brain.
I have a question from Chapter 9's balloons.
Alright. Oh. Does it involve the balloons?
I think so.
Okay. I'm glad you asked, actually, because even if it's not the one I'm thinking of, I just remembered something that I needed to tell everyone. This is Chapter 9 quiz.
Yeah.
Was it the first one? Okay. I'm very glad you asked. So, this is the Chapter 9 quiz. And question 1 is about several balloons being used to lift a person up. I worked this one through with the last class, and what's happening here is, to determine the buoyancy on a balloon, you need to use the buoyant force equation, and to that end, you need to know the density of the fluid the object is submerged in, the volume of the object itself, and G. Now, balloons are spheres, and that you are told the radius of the balloon, so for that, one should really just need to use the sphere volume formula. And on homework, I do generally consider the internet to be just open access for Googling constants and like geometry formulas and stuff like this. Like, you're doing the homework online. You can use the tools available to you. The issue that I'm now having with this question, after it was brought to my attention earlier, is the buoyancy formula says you need the density of the fluid the object is submerged in. And the helium balloon is the object, and the fluid it's submerged in is just air. Meaning you need to know the density of air, which the question doesn't list for some reason. When you look up the density for air, the first number that I was presented with was a density of 1.225 kilograms per meter cubed. And working this question through all the way through with that density did not give me the answer that Phys1500 was expecting. And then basically worked it in reverse, starting with Phys1500's answer, working back to the density of air. And this appears to be the air density that Phys1500 calculated based on. 1.289 kilograms per meter cubed, which is more dense than the other one. Could be that this guy's from England, maybe the air's thicker there, it's at least colder. And at least one of the students who specifically asked and was working the question out as I was talking about it, used that density and got the correct answer. So this ideally is just the density Phys1500 is using, and it should work for everybody. To anyone who's been having trouble with this one or perhaps hasn't started it yet, question again is, the first thing asked is, what is the buoyant force on the 600 balloons lifting this person? Buoyant force is low density times volume times G. This should be air's density. This would be the volume of a balloon. Just consider that to be, again, a sphere. And G, this would give you the buoyancy on one balloon. You have to multiply that by 600. Is that working better?
Yeah, I got the answer.
Okay.
Thank you.
I'm glad you asked. Is the rest of the question feeling okay with that? With that sort of? Yes.
So you multiply the 600 on at the end after you got the force of one balloon?
Yes. I suppose hypothetically, you could just multiply the volume by 600 at the start, but at some point you need to multiply by 600. I choose, when in situations like this, I try to find one single object and then multiply by the number of objects. Any other questions related to chapter 9 homework quiz for right now? Well, I've got this one up actually. Question 1, part C, is about why the balloons start popping. Are you familiar with the fact that balloons pop when they go too high up in the atmosphere? And do you happen to know that? Do you have the explanation for why that happens? Same reason they explode in space. Balloons pressurized for surface level atmosphere. So if you blow it up down here, the pressure inside should be the same as the outward pressure. Right? The outward pressure inside should be the same as the inward pressure inside just from the atmosphere. But you might know from chemistry that as long as the amount of gas in here doesn't change and the temperature doesn't change, it's going to try to occupy the same volume and the same pressure. But as the balloon gets higher up, the outside pressure starts dropping, right? And that means that the balloon isn't being compressed as much, so it's naturally going to expand and take up more volume for the same amount of pressure from the inside. And eventually it just expands to the point where the rubber physically can't stretch anymore and it pops. Which, again, same reason they pop in space, and the same reason that humans pop in space, grossly. All right, let's then look at any and all possible information you could need for the upcoming test. Do please interrupt me with any stray questions at any time. Today is the 10th. Next week, the 13th to the 17th is test week. And as per last time, you can take the test any lab time during that day. There isn't a lab. You're just showing up during lab so that you have as much time. You have the lab time rather than lecture time to do it. Yes?
So the week after, are we gonna have that?
Good. Okay, so thank you for asking. The week of the test, we don't have lab. The week after, we also don't have lab because that's Thanksgiving. So we have normal class on the 20th, but we're not going to have a lab that week because Thanksgiving break starts on the 22nd, and that if a week cuts off a few lab days, I just cancel lab so that no group gets ahead of each other. So no lab for the next 2 weeks. There is still lab today, if you haven't come to lab yet this week. But no lab for the next 2 weeks. There will be one final lab the 27th through the 1st. And likewise, we will have one final chapter that we cover that week in lecture as well. It'll be about waves and then specifically sound waves. Then after that week, we have one last day of class on Monday the 4th. That will be exam prep and closing out the class. Reading day is Wednesday the 6th, and then our exams are various times these 2 days. You can pick one of the 3 listed there. Officially, this course's exam is the last one there, I think, Friday at 5:30 p.m. So that might be the one that is designed to fit in your schedule, but if your schedule allows for either of the others, you can just show up then. I'm going to be here giving the same exam anyway, I don't care. But the main thing coming up is test next week. No lab, instead report for test. You can come any day that there is normally lab, which means don't show up Thursday. Thursday is the myth. And lecture will, as per the last test, also be focused pretty much exclusively on review stuff. So looking over the practice test, looking over homework and quizzes you're working on, answering questions from you guys. That'll be what lecture's about. And if you don't need that at any point next week, then you can take the rest of the lectures that week off. Yes?
Is the practice test already up?
It is. Thank you for asking. So I'm glad you guys are asking, but you're asking things I was gonna mention anyway, so you're just throwing off my internal script, which is fine, I can adapt. There we go. Oh, well, there we go. As for test studying materials, where did Brightspace go? There it is. I have updated both the test 2 tab on Brightspace and also the practice test contained within it. You guys don't see these files, I hid them, they're old, so you don't want them, you want this one, which you can't see. So the updated practice test is there. We can look at that today as well, but I also want to look at the concept list that you see if you click on the tab itself. I'm going to run down this list to make sure that you have heard from me exactly what you need to be able to do on the test and what sorts of questions will be on it, in as absolute terms as I can give. Any questions first? Yes.
About as long as the first.
Yes. Both tests are 9 questions. Of those 9 questions, 2 of them are very short answer on the first page, and then 7 of them are based primarily around algebra, but you still earn points for everything you write, including paragraph answers, if you want to describe what's happening more so than calculate it. So, 9 questions total, 105 points spread across them, graded out of 100. 7 of them are designed around math, 2 of them are concept short answer exclusively. And then the exam, the final exam, that's a month out, but just to mention it, since that's basically test 1 and test 2 combined in terms of both length and subject matter, that's looking to be about 18 questions. Maybe less if I end up combining a few concepts. Alright, so, again, my goal here is to make sure you know specifically what types of questions to expect. So, this, like with test 1, this list is everything covered in the chapters listed here, 6 through 9. Although technically kinetic energy was covered in chapter 5, but we used it all throughout chapters 6 and also 8. So, you still need kinetic energy, so it's still on this list. The reason you need kinetic energy is because in chapter 6 we looked at momentum and collisions, and you have to remember what type of collision kinetic energy is conserved in and which type it is not. So chapter 6 is the blurbs momentum through collisions. Momentum was the measurement of how difficult an object is to stop while it is in motion. And we primarily looked at it through the lens of conservation of momentum in a collision. Total momentum before is equal to total momentum after, and we use this as our starting point for any collision type questions, usually where one object physically collides with another. There were 2 types of collisions we looked at, those being elastic and inelastic. You do have to know the difference between them, both to use in math, but also because I might ask you to write out the difference between them. Suggest. What is the difference between them while I'm thinking about it?
Elastic collisions conserve both kinetic energy and momentum, while elastic collisions conserve momentum.
Correct. Momentum is conserved across all types of collisions because there is only one form momentum can occupy. In only elastic collisions is kinetic energy also conserved alongside the momentum. And your formula sheet does kind of make mention of this. When examining collisions, there were 3 main ways we would examine them. First of all, we can look at the momentum before and after. That works for any type of a collision. I'll always tell you what type of collision something is in a question. You don't have to guess. And regardless of type, this is a way you can analyze it because momentum's conserved, regardless of type. These two methods are comparing kinetic energy initial to kinetic energy final, and also just directly comparing the velocities of the two objects. This one is on your formula sheet. Note very specifically the positions of the two objects change across the two sides. That's important. The formula breaks if you don't arrange it like that. These two only work for elastic, and your formula sheet should point that out. But you can only use these if the question says elastic collision. So you have to know that you have to be able to know the difference both in terms of how you treat the math, but also in words, because I might ask that. Strongly suggest, nudge, nudge. And there is a practice test question related to collisions. I'll tap over to this occasionally to kind of demonstrate what I mean. On the practice test, number 10 is a collision question. The base premise is just two objects colliding with each other. And I ask, and will show in the answer key that I post this afternoon, how to treat it inelastically, and also separately how to treat it elastically, just to demonstrate the difference between the two. Elastically, the objects tend to stick together, and that means they have the same final velocity. Inelastically, this is your only option for analyzing it, but as long as they stick together, it's the same final velocity for both objects, and you only got one thing to solve for. Elastic tends to be more complicated, because if the objects bounce away from each other, you don't necessarily have the same final speed, and you can't make it the same variable twice. So we often run into a two equations, two unknowns type scenario in an elastic collision if you don't know either final speed. And that's why we have three equations here, so you can do two equations, two unknowns, if the elastic version requires that. So for the elastic version here, since you don't know either final speed, my answer key will show the method I recommend for finding the two final speeds. Two equations, two unknowns trick. You just have to pick two of these three starting points, bless you. And I highly recommend picking momentum and this third one, because the kinetic energy one has a squared in it, and that's a big pain. So, chapter 6, the type of question you mostly have to do will boil down to collisions, both the math for the collision and also remembering the difference between elastic and inelastic. And this one practice question will kind of serve as an example of both types. Oh, also, I almost forgot. Chapter 6, also we define impulse, which is just to say change in momentum, and how force causes change in momentum. And that was all the chapter 6 stuff. After chapter 6, we did chapter 7, which was our introduction to rotational motion. The first things we covered were just defining rotational motion, angular displacement, velocity, and acceleration. When I put that on the checklist, what I'm intending for you to do is look at these formulas, offset against their linear counterparts, understand what they mean, understand that they work the same way, but it's about radians and spinning instead of meters forwards. And then also be able to convert back and forth between the two forms using that middle transformation column. Because in the case of, say, a rolling wheel, the object is doing both at the same time, and the two are tied to each other based on the radius of the wheel. Chapter 7 also contained centripetal force and acceleration. First thing I'm going to point out about that is I'm going to ask a question relating centrifugal force to centripetal force. What is centrifugal force? guys muttering about it, but my ears aren't great and I can't read lips.
It's like kind of hard to explain because it's like it doesn't exist, but it's kind of there.
That's the main thing. It's not a real force. Centrifugal force is a sensory phenomenon caused by momentum and inertia. But it's not actually a force. Not arguing with what you feel, but it's just not a force causing that feeling. So the main thing to remember about centrifugal force is it's specifically a fake force. And I always remember that growing up because there's an F in it, F for fake, or F for fictional. Whereas centripetal is P for pretty real. I don't know. Choose your own mnemonic device. So, in contrasting centripetal and centrifugal, centripetal is the real numerical force that we calculate and use in our formulas. Centrifugal force is not a real force. So if I ask you to compare the two, that's the comparison. Now, one of the main things we did with centripetal force is combine it with universal law of gravitation. That's the formula that lets you calculate the force of gravity between any two objects based on their mass and how far apart they are. Yes?
When you said comparing centripetal and centrifugal, are you just saying give the definitions of both?
Yes. Focusing primarily on what's different between them. Namely, centripetal is a real force that points inward. Centrifugal isn't a real force, but it feels like it pulls outward. And again, make sure that the practice test is good practice. I put that on the practice test, and so it will contain the answer I would expect. Or the answer I would write. The answer key will fit. I'm rambling at this point. Main thing we did with centripetal force was combine it with universal law of gravitation because that is how orbit works in space. That's because a real existing force has to play the part of centripetal force. It's not its own separate entity. It is a part that a force has to be has to play. And in space, gravity is what plays that part. Earth and moon. Earth's gravity pulls in on the moon wants to move forwards, both happen at the same time, and it accelerates continuously around the planet. It falls continuously around the planet. So, the main application for centripetal force and universal law of gravitation on the test is going to be how they work together to cause orbit. So, these two things, centripetal combined with gravitation, the math you're going to have to do for that is orbit math. And for an orbiting question, which won't always be moon and Earth, it could be, a satellite in the Earth, it could be Earth around the sun, it could be any two things in space, as long as one of them is big and the other's spinning around the first. For those types of questions, very specifically, the force of gravity acts as a centripetal force, so you set the two equal to each other, and then you fill in the formulas for each on the either side. For FG, you want to use the big universal law of gravitation formula because mg doesn't cut it in space. And then for FC, you want to plug in either of the two centripetal force formulas. Whichever you use just kind of depends on what you know or what you want. If you know V or want V, use this version. If you know omega or want omega, use this version. Because the moon does have an angular speed. Its linear speed is really fast. It's moving at least Mach 3. But its rotational speed is actually really slow because it takes 24 hours to do a whole lap. And from here, you would then simplify and solve for whatever I asked for as part of the orbit. So you have to be able to do this. And there is an orbit practice question on the test to help with that. You get points just for setting them equal to each other, just for plugging things in. I want you to really remember and focus on this part right here. But I want to point out a couple small things that you need to make sure to remember to be able to do this right. One, It's the same R in every single part of every single parts of these formulas, every single part of every one of these formulas, because they're both indirectly referring to the same thing. Gravity cares about the distance between their centers of mass. Centripetal force cares about the distance from this object's mass to what it's orbiting around, and what it's orbiting is Earth's center of mass, because gravity is what's causing the orbit. So it's the same R for all of this, and that's always the orbital radius, not surface to surface radius, orbital radius from center to center. But it's the same R on all sides, meaning that they're gonna probably combine or cancel in some weird ways. Beneficial ways, in my opinion. It'd be way worse if it was a bunch of different radii all over the place. The other thing to note is that the masses over here is gonna be the same as one of these two masses, and you have to pick and remember which one it should be the same as. There's two objects here, the orbiting object and the object being orbited. Which of those two has centripetal force acting on it? Orbiting. So the orbiting object has its mass go here, whereas both masses go on the other side. Gravity depends on both, but that gravity acts as a centripetal force only on one of the two. So, whichever one is being acted on goes here, and that means that in this example, that'd be the moon, and weirdly, the moon's mass is gonna cancel out across both sides, which just implies that any object, regardless of mass, would have to orbit at the same speed at the distance the moon is from the Earth. So, orbit question, set FG equal to FC, same R in all the formulas, note which M has to go on the centripetal side. Questions about that genre of question that will be on the test. All right. That was chapter 7. Next came chapter 8, which was more rotational stuff. Moment of inertia, which is to say that if a question mentions that a cylinder is rolling downhill, specifically it's spinning, then that is your invitation to look at this back page, find the formula for moment of inertia of that shape, and it will be used for the rotational parts of that question. I'll always tell you what shape you can treat something as, and it will always be one of these. And you need moment of inertia because it's the counterpart of mass, and any linear formula that had mass in it, its angular counterpart has I for moment of inertia instead. So those concepts include torque instead of force, rotational kinetic energy instead of linear kinetic energy, and angular momentum instead of linear momentum. So you'll have to, if I say again, tell you a cylinder rolls forward, find the correct moment of inertia formula for that cylinder, and then use it in any of these relevant rotational formulas as they come up. Out of these additional rotational concepts, I'd say torque is probably the one to focus on most, because we did unique torque balance beam questions. So you do have to be able to create a balanced torque scenario and figure out where all the pieces have to go so that it balances correctly. Main premise there is, for something to be completely level and not rotating, net torque has to be 0, and or clockwise has to equal counterclockwise. Basically, the lab we did last week, was that last week? Last week's lab is good practice, so if you reclaim your lab document from that and look over it, that's good practice. There is also a balanced object practice question on the practice question on the practice test is what I'm trying to say. And that was chapter 8. These last 4 blurbs are just a summary of what we did this week. Density, pressure defined as force over area, pressure at depth in a fluid, and buoyant force. For buoyant force, I'll point out, you will have to figure out the buoyant force on an object that is floating, And you'll have to remember that if something floats unassisted, its buoyant force must be equal to and counteracting its weight. The two rules for if something floats are if buoyant force is currently equal to its weight, and if its density is less than the density of the fluid it's trying to float in. So there'll be at least one floating object. You have to remember that fact about weight compared with buoyant force. And that is the test in a nutshell. It's the types of things you need to be able to do for it. How you guys feel? All right. The practice test that is now posted, it's been fully updated, has sample questions for all of these related concepts. And obviously they won't be exactly the same, but if you can do the practice test, I feel confident you'll be good to go on the test itself. I will point out again, I always make the practice test both longer and more difficult than the test proper, because I'd rather you make mistakes on it than the actual test. So if you're struggling on the practice test, that is also separately okay. It's designed to be the trickier of the two documents. And I'll be posting an answer key for it this afternoon. How you guys feel? Anything on your minds about the test or even any homework or quizzes you've been working on? All right. No, that's pretty much everything I wanted to get through today. So, at this point, we can either close it down for the weekend, or if you want to keep studying in the room, and if in case a question pops up, you are allowed. But that's the end of it for today. Do let me know any questions you have while studying. I do recommend studying over the weekend, but as a reminder, lecture next week will be review sessions. So we have time to study in lecture as well. And then you can pick which day you take the test as long as your schedule allows for it. And it's always in the afternoon, so the morning sessions are always still in the afternoon. Bring questions next week so we have something to talk about, because if we don't, I'll make something up. Talk about superheroes. Yes?
So, lab next week is class, the lab after that is there.
There is no lab next week because test. There is no lab the week after because of Thanksgiving. The last lab, we only have one more, will be the week of the 27th through the 1st. That is the last one. Have a great day and weekend.
Thank you.
Thanks. Appreciate you all.